Hey guys, my name is Will Buchanan, and this is my Lab 3 for Physics 2211. So the objectives of this lab, there were two parts. The first part was to determine the mass of a black hole in the computer simulation using other components that were given, such as the mass of the star and a couple other things. And the second objective of the lab is to find the initial velocity required for our theoretical spacecraft to escape the gravity of the black hole with simply just an initial velocity and nothing else. And the initial velocity required to escape is dependent on the mass of the black hole. So finding an accurate velocity in part 2 is dependent on an accurate mass in part 1. And these are some important formulas we use throughout the lab to do our calculations. We have Newton's second law, momentum, the parallel component, the velocity update formula, the gravitational force formula, and the mass of the black hole, which can be derived from the gravitational force formula. And this is the code used for part 1. And there's a whole lot going on. We have our positions up here, our unit vectors, and our forces down here. And here this is where we set up the arrows, which actually show how the forces act on the star throughout the process. And let's see our code in action. So we see our star rotates around, and both force components increase greatly as it gets closer to the black hole, which is as expected. And as the star gets farther away, the force components decrease. And the mass of my black hole was found to be 7.04 times 10 to the 34 kilograms. And all of our black holes are unique because it uses characters from our email address. And what is the difference between the net force and change of momentum? So net force and change of momentum are related, but they're not the same. Net force is the total force acting on an object, where rate of change of momentum is the object's momentum over time. And basically, to sum it up, they're related and very closely connected, but they're not the same. The net force is the cause of a change of an object's momentum, while the rate of change of momentum is the effect of the net force. And for the perpendicular and parallel components, the parallel force component can cause a change in the object's momentum because it can cause a change in speed, and momentum is mass times velocity. So a change in velocity will cause a change of momentum, whereas a perpendicular force component can only change the direction of the momentum, but it can't change the actual magnitude of the momentum because it cannot affect the speed. It only affects the direction. And on to part 2, where we look at our spaceship trying to escape the black hole. And for the initial velocities, there are a range of values that work, and the ones that are listed just happen to fall into that range. So here's the code used. Here's our parameters set up here. And then we have our position, which is found by subtracting the planet position, by subtracting the black hole position from the planet position. And then we use the gravitational formula to find the force of the black hole on the planet and the force of the ship on the planet. And then down here, we find the planet velocity and planet position, as well as the ship velocity and ship position. And these were the velocities that ended up working for the spaceship, which allow it to escape. And let's see that in action. So this is our spacecraft, and it successfully bends around the black hole and escapes. And it avoids the orbiting planet, which is in teal color over here. And these are the speeds I used to escape the gravity of the black hole. And this question asks, what if we didn't want to escape the black hole, but instead go into orbit? So this involved me just basically testing a ton of different velocities. And I got pretty close to achieving orbit. It was difficult to both avoid crashing into the black hole and not escape completely. And this is the closest I was able to get. And maybe it would have gone into orbit if I had more time or if I increased the time in the loop. But this was the closest I got, and these were the speeds used. Thanks for watching.